Good day, everyone. Welcome to another fun learning episode in science. Have you ever listened on the radio? Talk on a phone with a friend? Lit a candle? Cooked on a microwave oven? Went to the beach and beat the scorching heat of the sun? Or perhaps had undergone medical x-ray? If yes, you have experienced electromagnetic waves. Electromagnetic waves are all around us. Some are unnoticeable, yet a lot of our activities make use of these electromagnetic waves, from texting to cooking. Hey, you know what? It's been a month that you have discussed this, and I'm waiting this for so long. I cannot take this anymore. I will now be the presenter. This is my time. My time! Okay, welcome to TV Eskwela, my turn. Hi everyone, I'm Sir Lloyd Luzano. We are Sir Lloyd Luzano, your Science 10 teacher from Mangayon National High School, and this is TV Eskwela.
After watching this video, the learners are expected to A. Compare the relative wavelengths of different forms of electromagnetic waves. B. Compare the relative frequencies of different forms of electromagnetic waves. And C. Identify the relationship among wavelengths, frequency, and energy of an electromagnetic wave.
Grade 10 learners, are you excited? You have learned about waves during your Science 7 class. Let's recall and review some important terms about waves. Here are descriptions of different terms relating to waves and the jumbled letters which will form the correct term. Your task is to rearrange the jumbled letters to form the term being described. Do this on a separate sheet of paper. Are you ready? Okay, I'm excited. Right, let's begin. Time starts now. Number 1, it is a disturbance in space. Abwe? That's the jumbled word. Sorry. Here's the clue. Oh, okay. That's a wave. Perfect. It is a wave. Next question. It is the highest point in the wave. Crest. Very good. Correct. Next, number 3. It is the lowest point in the wave. Trough. Nice. Correct. Here is number 4. It is the distance from the midpoint to the highest point or the lowest point of the wave. Dialmol putol? Haha, wrong. It's the amplitude. Oh, I remember. Amplitude. The higher the amplitude, the greater energy it carries. Correct. Next question. Number 5. It is the distance between two successive identical parts of a wave. Wavelength. Correct. Here's the image of a wavelength. Next, it refers to the number of waves produced in 1 second. I know that. It's frequency? Very good, my friend. You are 5/6. Not quite bad. When you move your hands up and down while holding one end of the rope, you create a wave on the rope. The waves you created may look different depending on how fast you move on your head. Similarly, if you move an electrically charged object back and forth in an empty space, you will create electromagnetic waves in space. But what is an electromagnetic wave? There were two scientists as proponents of electromagnetic wave. They were Ørsted and Michael Faraday. According to Orsted, electromagnetic radiation is a wave that is created as a result of vibrations between electric field and magnetic field. A changing electric field produces magnetic field. Moreover, Michael Faraday, the changing magnetic field will produce electric field. And these waves carry energy as it moves. So, therefore, electromagnetic waves travel as vibrations in electrical and magnetic fields, meaning electromagnetic waves need electricity and magnetism for it to be able to travel. Wow, isn't that amazing? Electromagnetic waves or EM wave can travel to anything. It can travel to both in a medium and a vacuum, or in an outer space. But all electromagnetic waves do not require a medium to travel through. This is pretty important because if electromagnetic waves could not travel through space, then the light and heat from the sun would not be able to reach us here on Earth. Like the light travels in the water, or a radio waves travels in the walls of my room and sends messages to your loved ones. Right, my friend? Hey, friend. Yes. Can't you see I'm talking here in my phone? Wow, sana all. So, how does a medium affect the speed at which electromagnetic waves travel? Electromagnetic waves travel at slower speeds when traveling through a medium, but they still travel 1,000,000 times faster than a sound can travel in air. Yes, absolutely correct, my friend. When electromagnetic waves travel through a vacuum or in an empty space, these waves travel at the same speed of 300 million meters per second, or in scientific notation, 3 times 10 raised to the power of 8 meters per second. Though they travel the same speed in a vacuum, they still have different wavelengths and different frequencies. So, as the wavelength decreases, the frequency of the wave increases. And do you know that light from the sun travels the 150 million kilometers to Earth's surface in just about 8 minutes? Isn't that amazing? Now, students at home, I want you to open your module on page 8 to 14. Take a look and observe the diagram. It shows that the electromagnetic spectrum are arranged according to frequencies, energy, and wavelength. Now let's go deeper and check out each of the electromagnetic spectrum by answering the Who Am I activity. Based on your observation in the diagram, you will guess of what type of electromagnetic wave depending on the frequency and the wavelength that I'll be asking. Now take note, the wavelength is the distance between crest to crest or the distance between trough to trough. And frequency is the number of wave per second. Are you ready? Yes, I'm ready. This wave has the longest wavelength, greater than 1 times 10 raised to the power of -1 meters, and the shortest frequency, which is less than 3 times 10 raised to the power of 9 Hz in the electromagnetic spectrum. It can be of the same size of a human, or could be a size of a basketball court. Imagine that. Who am I? Oh, I know that. Based on my observation, I think radio wave is the longest wavelength and the shortest frequency. Yes, you are correct, my friend. Radio wave is the longest wavelength and the shortest frequency. With this range of wavelength and frequency, radio wave can be used to transmit sound and picture information over long distances. It can be seen in the GPS or global positioning systems in order for us to be located where are we on Earth. It is also used to connect the satellites in order to receive signal and gives us direction. Now your turn. Okay, my turn. This wave is opposite to a radio wave, which is the smallest wavelength, 1 times 10 raised to the power of negative 11 meters. The highest frequency, greater than 3 times 10 raised to the power of 19 hertz, and the most energy of the waves in the electromagnetic spectrum. These waves are generated by radioactive atoms. In nuclear explosions, they can even kill living cells, but the doctors can use them to kill diseased cells. Who am I? So far, based on the diagram, it is gamma ray. Absolutely correct. You're very smart. Do you remember Hawk, the Green Man in Marvels? He was injected by this gamma ray and caused him to be very strong and become a superhero. But in reality, this range of frequency and wavelength used to detect cancer cells. Hahaha, I know, right? Next question. My turn. These waves are the only electromagnetic waves we can see. We see these waves as the colors of the rainbow. Each color has a different wavelengths. Red has the longest wavelength, 6.22 times 10 raised to the power of negative 7 meters to 7 times 10 raised to the power of negative 7 meters, with a frequency of 4 times 10 raised to the power of 14 to 4.82 times 10 raised to the power of 14. And violet has the shortest wavelength of 4 times 10 raised to the power of negative 7 meters to 4.55 times 10 raised to the power of negative 7 meters, and a frequency of 6.59 times 10 raised to the power of 14 to 7.5 times 10 raised to the power of 14 hertz. This range of frequency and wavelength of this wave combine to make white light. These waves are essential for photosynthesis. And without photosynthesis, plants cannot be able to produce oxygen and food for us human and animals to survive. Who am I? From the word itself, visible, I think the answer is visible light. Absolutely correct. Visible light. Next question. These waves have wavelength shorter than visible light waves, with a wavelength of 1 times 10 raised to the power of 8 to 4 times 10 raised to the power of negative 7 meters. Same size from that of a molecule, and with a frequency of 7.5 times 10 raised to the power of 14 to 3 times 10 raised to the power of 16 hertz. These waves are invisible to the human eye, but with this range of frequency and wavelength, some insects can see them. Of the sun's light, these waves are responsible for causing our sunburns. Who am I? I've gone to the beach last time and my skin really burned. My answer will be infrared. Wrong! It's ultraviolet ray. Now your turn. Next question. These waves have smaller wavelength than radio wave. Same size of the 1 peso coin. 1 times 10 raised to the power of 3 to 1 times 10 raised to the power of negative 1 meters, and a frequency of 3 times 10 raised to the power of 9 to 3 times 10 raised to the power of 11 hertz. With this range of frequency and wavelength, this range is used in satellite communications, radar, television transmissions, and cooking. Like in a microwave oven, the wave transfers energy to the water in the food, causing them to vibrate, which in turn transfers energy in the form of heat to the food. As a result, the food is cooked. Who am I? From the range of the wavelength and frequency, my answer will be microwave. It's very obvious, my friend. It's microwave. You are correct. Let's move on to the next question. As wavelengths get smaller, The waves have more energy. These waves have smaller wavelengths, 1 times 10 raised to the power of negative 11 to 1 times 10 raised to the power of negative 8 meters, and a frequency of 3 times 10 raised to the power of 16 to 3 times 10 raised to the power of 19 hertz, and therefore more energy than the ultraviolet waves. These waves are so powerful that they pass easily through the skin, allowing doctors to look at our bones. Lifetime exposure to these waves can cause defects in cells. Who am I? Yes, even pregnant women are not advised to expose to this kind of wave because it will only lead to miscarriage. My answer will be X-ray. Am I right? Yes, you are absolutely correct. Yes, my turn. This type of wave is significant at both short and long wavelength. The ones with long wavelengths, 1 times 10 raised to the power of 3 meters, can be detected as heat. Your radiator or heater gives off these long waves. The sun gives off this type of wave with a shorter wavelengths, 7 times 10 raised to the power of negative 7 meters, and a frequency ranging from 3 times 10 raised to the power of 11 to 4 times 10 raised to the power of 14 hertz. Plants reflect these waves. These waves are used for heat detection, cameras for night vision pictures, and even security systems in military operations. Who am I? Infrared radiation. You are very smart. Correct, infrared radiation.
Now, grade 10 learners, I want you to look and observe the electromagnetic waves based on the wavelength and frequencies given. On page 15 of your module, answer the enrichment activity. Identify what happens to the wavelength, frequency, and energy of the electromagnetic waves following the directions of the arrows. What happened to the wavelength of the electromagnetic wave from radio wave to gamma ray? Correct, decreasing. Next, what happened to the frequency of electromagnetic wave from radio wave to gamma ray? Correct, increasing. How about the energy from radio wave to gamma ray? Absolutely correct, increasing. Can you see the difference? What differentiates them? Correct, it's their wavelength and frequency which is inversely related, which means that when one goes up, the other goes down. However, its frequency and energy is directly related, which means that when one goes up, the other also goes up, or when one goes down, the other also goes down. On page 16 of your module, answer the assessment. Pick out the correct answer and use a separate sheet of paper for your answers. Number 1. Which has shorter wavelength? Correct, gamma rays. Number 2. Which has higher frequency? Correct, ultraviolet. Number 3. Which has more energy? Correct, infrared. Number 4. Which has longer wavelength on visible light? Correct, green light. And number 5. Which has lesser frequency? Correct, microwave.
Alright, here in the diagram, moving from left to right is an increasing frequency and energy and highest ionizing radiation, but decreasing in wavelength. So, the radio waves have the longest wavelengths, but the smallest frequency and smallest energy and lowest in ionizing radiation. And the gamma rays have the smallest wavelengths but the highest frequency, energy, and highest ionizing radiation. How are frequency and wavelength of electromagnetic waves related? As the wavelength of an electromagnetic wave decreases, the frequency of the wave increases. Waves with the longest wavelengths have the lowest frequency. Waves with the shortest wavelengths have the highest frequencies. How are frequency of a wave and wave energy related? The amount of energy carried by electromagnetic waves increases with frequency. The higher the frequency of a wave, the higher its energy. Electromagnetic waves have different wavelengths. The wavelengths of radio waves have multiple kilometers to less thousands of nanometers in gamma rays. Waves in the electromagnetic spectrum vary in size from very long radio waves as the size of that of a building, to very short gamma rays, which is smaller than the size of the nuclei of an atom. Isn't that amazing? Now, grade 10 learners, you have learned that wavelength is inversely related to frequency, which means that they are opposite in their direction, whereas frequency is directly related to its energy, which means that they are the same in their direction. Same with what happened to the law of supply and demand. The law of supply is essentially the opposite of the law of demand. Typically, increasing the price of a mango, for example, during Christmas Eve, will result to the lower demand, whereas decreasing the price will also increase the demand. However, if the price of a mango increases, the supply of a mango also increases. That's what happened during after Christmas Eve.
What I have learned. At this point, let's sum up what you have learned. Pick out the word that will make the statements correct. Write your answer on a separate sheet of paper. The electromagnetic spectrum is the arrangement of correct electromagnetic waves, which are waves that are created with changing electric field, and correct magnetic field. EM waves travel on correct vacuum at a constant speed of correct 3 times 10 raised to the power of 8 meter per second. The electromagnetic spectrum is arranged in a manner of correct decreasing wavelength. Correct increasing frequency, and correct increasing energy. Wave has the longest wavelength, lowest frequency, and lowest energy among all EM waves. Correct radio wave. It is the only EM wave that can be seen by our naked eye. Correct the visible light. Whereas it has the longest wavelength. Correct red. It has the greatest frequency. Correct violet. On the other hand, it has the shortest wavelength and highest frequency. Correct gamma ray, which carries the highest among all EM waves. Correct energy. Therefore, it has the lowest ionizing radiation. Correct, radio wave, while has the highest ionizing radiation. Correct, gamma ray. What I can do. For sure you are now acquainted with the different electromagnetic waves. It's your turn to make your own chart about electromagnetic waves. Make a chart of electromagnetic waves showing the comparison of its size. Cut out pictures of objects or look for things that may represent the size of each electromagnetic wave. On a separate sheet of paper, paste the pictures you have found and arrange them according to the arrangement of EM waves in the electromagnetic spectrum. Here is the standard rubric. You'll be rated by your teacher according to the following criteria. Accuracy of information, 5 points. Neatness of work, 5 points. And appropriateness of materials, 5 points. And a total of 15 points. Good luck and enjoy!
There you have it, my dear science and learners. I hope you've learned from this video. For more fun science learning, tune in again next time. This has been Sir Lloyd Luzano from Mangayon National High School, Compostela East District. Your science 10 teacher, saying, despite this COVID-19, be a Pluton. Think positive, keep calm, and do science. At dito sa TV Eskwela, sa pag-aaral, sama-sama. Bye-bye!